Hey everybody, welcome back into another fun and exciting Algebra 2 class. Today we are going to be talking about how to solve linear inequalities. Last class we kind of introduced them. We talked about the vocabulary words. We talked about how to graph them. We talked about how to use the inequality notation and so I think we kind of got the groundwork laid last class. This class, we're actually going to take that groundwork and we're going to apply it to problems and see how that works out. All right, a couple things that I wanted to talk about real quick before we get started, a couple of the rules and a couple of the things to remember as we're solving these. First of all, the biggest rule to remember is you're going to solve these just like a normal equality, so like a regular equation. The only difference is this: when you have a multiplication or a division by a negative number, you have to flip the inequality. And I think in a little bit you'll understand exactly why you have to do that. But for right now, just learn the rule, and then pretty soon as we keep doing these, you're going to go, oh, okay, I get it. I understand why we have to do that. So for right now, just learn it. Learn that rule. Every time you are multiplying or dividing by a negative number, if it was a less than sign, you have to flip it to a greater than sign. If it was a greater than sign, you have to flip it to a less than sign. And we'll go over that in just a minute as we're going over some of these. But that's the number one thing that you need to remember right here. All right, so let me write down just a couple things. I want you to think about these steps as we go through this. So these are steps for solving inequalities. I won't write that. I'll just write the steps. The first thing that you need to do is you need to solve the inequality. And you might think, well, then I'm done. I solved the inequality. No, there's a little bit more to these, okay? So solve it just like you would solve an equation. Remember that whole negative dividing or multiplying by a negative thing, okay? The second thing is we are going to graph the inequality. So we're going to solve it, then we're going to graph it. The third thing that we're going to do is we are going to test points. You'll see what that means in just a second. That's kind of a new thing maybe that we haven't really talked about a lot, but we're going to test some points. All right, so basically once we get these all done, we are going to check it, and this is kind of the check right here. You could also write check. This is how you check it, is by testing points. All right, so we'll keep coming back to that in just a second as we're working through some of these. If you're wondering where we are in your book, we are on page number 71, page 71. So let's do this one. Let's do this example. 3x plus 2 is greater than 5. 3x plus 2 is greater than 5. Now, go back to our steps. First step, solve the inequality. So let's solve this thing. Let's see what we come up with. So we just want to do our regular things that we do with an equality. You can almost pretend like that's an equal sign. It's not, but you can pretend that. The only thing that changes that is if you multiply or divide by a negative number. Everything else stays the same as a regular equality. So minus 2 minus 2. Cancel. 3x is greater than 3. Divide by 3, divide by 3. X is greater than 1. There's our solution. Now, this, I need to take just a second and tell you what this is right here. The book calls this, and mathematicians call this, a critical number. And the reason it's a critical number is because that's the number that gets grafted. That's the number that we put onto the graph. And so that's important to know. And sometimes you get one critical number, sometimes you get 2 critical numbers, sometimes you get 5 critical numbers, 100 critical numbers, whatever. Depends on the equation. So in this case, we got one critical number. So we would come to our graph, and okay, so solve the inequality. We did that. So we got our critical number. So we're going to graph the inequality. That's the next step. So here we are graphing it. And we will call this 0. We'll call this 1. We'll call this -1. We can do 2. We don't need to go any farther because our critical number is 1. We don't need to keep going any larger or smaller here. All right, so now, if you remember from last lesson, with this critical number of 1, we are going to circle the 1. We do not color in the 1. Why not? Because it's not equal to. If that was equal to, we would color it in, but it's not equal to. So it's open. That's what we call that when we don't color it in. It's open. And then it goes into, it's greater than, so it's going to go to the right. It's going to go this way. Now, before we do this, or before we actually write that on there, and this is going to, like right now you can see that. You're like, oh, yep, that points to the right, so that means it goes to the right. I know, okay, I know that you think that, and I know that maybe you've heard other teachers tell you that, but we need to be careful right here because some of these are going to start getting complicated, and some of these are going to have weird things going on with the signs. Some of these are going to have like 2 is less than x is greater than 1. We're going to get what's called compound. And so all of a sudden we're going to have weird stuff going on, and we need to make sure that we test these. All right, and so that's this right here. Test the points. So after we graph, we're going to test the points. Before we draw our lines, before we say, okay, this is what actually happens, we're going to test our points. What does that mean? Well, you always test 1 point to the right, 1 point to the left, and then 1 point in the middle. Well, this one doesn't have 2 numbers, but let's say it had those. So we would test 0, we would test 2, and we would test -2. That should be negative right there. But in this one, we don't have anything to, we only have 1 number. So we only need to test, we don't need to test any middle numbers. And you'll see middle numbers in just a second, especially once we get to compound inequalities. But on here, we're just going to test 1 here and 1 here. So let's just test these points. And what do I mean by that? Plug them in for x. 0 is greater than 1. No, 0 is not greater than 1. Okay, so this side doesn't work. Let's try the other side just to verify this. 2 is greater than 1. Yes. And so we will come out here and we would draw our arrow, or we would graph our line going greater than. And like I said, yes, it works looking at this. Oh, it's pointing right. I'm just going to graph it to the right. That worked for today. That works for right now. But that is going to go away very quickly, and you are going to have to test your points. If you don't test your points, you're going to get them wrong. Okay? So let's write this. The last thing to do, I guess I could write a step number 4, is, and you could really write this kind of after, you could write this as a step 3, and this is, and change step 3 to step 4, but it doesn't matter. And then you could write as interval, got a fly bothering me, interval notation. Okay, write as interval notation. So let's go over here and let's take this and write it as interval notation. How do we do that? Well, we go over here and we say, okay, so our critical number was 1. So we want to write our critical number 1. Does it include 1? No. So it gets a parenthesis. 2, that's the comma, that means 2. Infinity, because it just keeps going right here. There's no stop. To infinity. Does it include infinity? No, infinity can't be included in interval notation. So infinity always gets a parenthesis. So there would be your interval notation. So you really have 3 answers here. Okay? So let me erase some of this so that you can see. So, all right. So here's the 3 answers. Get rid of quickly. All right. So answer number 1 is that. Okay, just the just with the notation that you've been used to, greater than, less than, equal to. Okay. Then I need you to also write the interval notation. That's the new thing that we learned in the last lesson. And I need you to be able to graph it as well. So these are all parts to the solution. I need to see all three different things to know that you know what you're doing. Okay? And so please give me all three of those answers when you answer a question here. Okay? All right. Let's do one more. Okay, let's do a compound. Now we're stepping up our game. Compound means more than one, okay? And so here's what we're going to do with this compound. We're going to do 20 is less than 10x is less than 30. So we got lots of stuff going on here. So remember what I told you, just solve. Just solve. Now, here's the weird part. We really have three things going on. So here's what I suggest that you do. Break this down. Do this and do this. You see how there's really two things? So you have this part. So let's write this one over here. 20 is less than 10x. And then let's write this one over here. 10x is less than 30. We've done this before, right, with absolute value, where we broke them down and did them in two separate things. All right. So you should be kind of used to this principle, this idea. Now what we want to do is just do the equation or solve the inequality. So we're going to divide by 10, we're going to divide by 10, and that's going to give us a cancel, and that's going to give us a 2 over 1 or a 2. So 2 is less than x. And now let's do this one. Okay? And so again, we're going to divide by 10, and we're going to get 3 over 1, or x is less than 3. So now you have really two sets of numbers here. You have two sets of what we call, remember, critical numbers. So these are our critical numbers. So let's go ahead and put our line here. And so we'll put 0, 1, 2, 3, and 4. That's really all we need. So because both of these are not including, they're not equal to, we're just going to put, these are our critical numbers. So we're going to graph our critical numbers. So let's put a circle on 2, and let's put a circle on 3. Now remember what I said when we get to these. You have to test points that are over here. You have to test points that are here in the middle. And you have to test points that are over here. So let's pick some test points. So test points. We're going to test, let's test 0. 0 is a really easy one to test. Let's test 2.5, because there's really no numbers in between here, so we're going to have to use a decimal. So 2.5, and let's test 4. So these are our 4 things that we're going to test. All right, now they have to work on both of them to pass the test. So let's go ahead and try this out. So substitute in 0 for both of those. 2 is less than 0. 2 is not less than 0. So 0 doesn't work. Okay, we know 0 is not going to work. So 0's off. Okay, let's try 2.5. 2.5 here. 2 is less than 2.5. Yeah, okay, so this one works over here. But now we got to test it over here as well. 2.5 is less than 3. Yes, that one works too. So the 2.5 works. And so what we'll do is with the 2.5, we say, okay, that one works. And so we need to color in the middle part right here. Now let's just check. Let's verify 4, because maybe 4 will work. Maybe it won't. We'll see. All right, so 2 is less than 4. That's true. 4 is less than 3. No. So 4 does not work. The only one that works is that middle part, that 2.5. So we would graph there in the middle, that 2.5. Now, we could write that in a way that let's see. We could write that now. Okay. Let's go back to this. So here's our solution. That's part of our solution. That's part of our solution. That's part of our solution. The one thing that we're missing is the notation. Okay, the interval notation. So really we have two interval notations that we have to write down. We have one for this one and one for this one. So let's write those down. So we would have 2. That's our first critical number. And it does not include 2. So we would put it here. And we would say, comma, what is our second critical number? Well, it's right here. It's over here. It's 3. And then it does not include 3. And so here is our interval notation, 2 to 3. And that is exactly what that says right there. Not including 2, 2, not including 3. And so this would be our answer in interval notation. It would be going from 2 to 3. All right. Well, that's all I have for you. The only thing that I really didn't show you that I talked about, but I do kind of need to show you. Let me show you really quick. If I have a -2 and I have a, let's see, let's put a 2x over here. Okay. If I, whoops, that's not what I want. I want -2x, and then we'll do that. If I divide by -2, when I divide by -2, I have to take this sign right here, and I have to change the sign. It's a rule. You have to do it. There's no way around it. Okay? You just have to learn that. Memorize that. Apply that every time you divide or multiply by a negative number in an inequality. You have to flip the sign. Super important. If you don't do that, then you will get the answer wrong. Okay? Your arrows will be going the wrong way. And so that's really the only other thing I need to just talk about there. Everything else, just keep working on it. Keep following those steps. Keep solving your inequalities the same way you do an equality, except for that right there where you divide by a negative number or multiply by a negative number. You have to flip the sign. Okay? All right, that's all I have for you in this lesson. We'll see you later. Have a good one. Bye-bye.